Section 4.2, the mean value theorem, page 1. We're going to start with Rolle's theorem. And Rolle's theorem says, let f be a function such that the three conditions are held. The function is continuous over a specific closed interval. It's differentiable over that same open interval. And there are 2 points that are the ends of these intervals such that their output is identical. If that is the case, there exists some number c that is in between this interval, somewhere inside the interval, such that the derivative equals 0. Now, we're used to seeing derivative equal to 0 when we talk about maxes or mins, and that can come into play. But basically, we're saying this is a derivative being 0 is just something we're looking for. Keep in mind, if c does not exist, it will only be because one of those 3 hypotheses are not satisfied. Here's a visual of what's going on. So I have some range from A to B, and A has a particular output that's identical to the output of B. The only way this is going to happen is either the graph is flat and then there's infinite C's, or somehow the graph has moved shapes in such a way that if we found a point and the tangent line being the derivative of the function, if that tangent line is horizontal, then that is the particular C. So over here, I have a tangent line, but because this is not equal to 0, it's not a horizontal tangent line, whatever that point is not considered C according to Rolle's theorem. My visual had 2 C values. You could have 10, you could have 100, you could have just 1. So let's go ahead and look at example 1. I'm given a function, and all I'm asked to do at first is find the output of 2 particular values. So I'm going to plug negative 64 in for x. I'm going to plug positive 64 in for x, and they both have the same output value of 0. This means condition 3 for Rolle's is met, that I have a start and end interval value with the same output value. Now, we also need this function to be continuous on the closed interval and differentiable. But let's just go ahead and look what question or part B asks. Find all values C, remember there could be 1 to 1,000,000 or more, such that the derivative of that C value equals 0. Well, that's going to be true by Rolle's theorem if all conditions are met. So let's start by finding that derivative. The derivative of 16 is 0. The derivative of minus 2x to the 2/3 is listed here. And now that I have my derivative, I'm ready to find out when does this derivative equal 0. Now, when I set the derivative equal to 0, some of you can just look at it and notice it's never going to equal 0. But let's assume it wasn't obvious. So we're going to cross multiply the 3 with the 0. We're going to cross multiply negative 2 with an invisible 1 as a denominator of 0. 0 times anything is 0. But negative 2 times 1 is negative 2. This is a false statement. There is no x to solve for, and I have something that's not true. So therefore, this does not meet Rolle's theorem. Now, it might seem like it's contradicting Rolle's theorem, but it's not. Like I just said, it means at least one, possibly more of the conditions is not met. Either our function is not continuous, although this is, or it's not differentiable, which that's the problem. This one's not differentiable. I wrote in really small writing. I don't know that you would have known this already, but this particular function, it has a cusp, a sharp point at x equals 0. So even though it's continuous through that point, it is not differentiable. Thus, there is a point in our interval that is not differentiable. Okay. So now, one other thing is, remember the intermediate value theorem? We use this to prove there's at least one solution. We can often use this in conjunction with Rolle's theorem. To restate the intermediate value theorem, If f is a continuous function and it has a negative output and a positive output, then there has to be what we refer to as a solution in the interval that these two outputs are creating. A solution is basically a root, or where the function, not the derivative, but the function equals 0. Example 2. Show that this equation has exactly one root. Well, first we just need to prove there's a root at all. So I'm going to take the function that's given, and for there to be a solution, there needs to be some a such that I plug it in and it gets 0. And we're going to prove that by first, with the intermediate value theorem, agreeing that this is a continuous function because it's a polynomial. Sorry, there was a stray mark. Then we usually start by plugging a value in, and we often are looking for negative, but I have to be truthful. I'll usually plug 0 in first, and I get an output of 1. Because this is a positive output, now I need a negative output. I can tell that plugging 2 in is just going to make this larger. So instead, let's plug -1 in. And because of the nature of odd exponents, I'm going to end up getting -6. So I have a positive output, a negative output, and therefore these two values are the interval that guarantees there is at least one solution in this particular function, and specifically it's in between 0 and -1. Now, we're supposed to prove that there's only exactly one root. I just proved there is one, but now I need to prove there's not more. So the way that we're going to prove that there is exactly one is, let's assume that there's more than one, specifically 2. Excuse me. And we want to prove that that's not true, that there aren't 2. So if there are 2 solutions, and a solution is when the function equals 0, there is some value a inside of 0 to -1 that equals 0, and another value b that also equals 0. We know that the range, the interval from a to b, is continuous because we're still working with a polynomial. Our whole function was continuous everywhere. And our original function was differentiable, so obviously a subset region of that function will be differentiable. So by Rolle's theorem, there has to be some value c such that derivative equals 0. So let's take this function, let's find its derivative, but I'm stating the derivative is never going to equal 0 because if you notice, we have 2 plus 3 times something squared. It doesn't matter what you plug in because you square it, it's going to be positive. 20 times x to the 4th power, it doesn't matter what you plug in, to the 4th power is going to be positive. And there's no way 2 and the sum of 2 other positive numbers can ever equal 0. So therefore, Rolle's theorem does not hold, and therefore we have exactly one solution.